Hey, Trick Class, let's do this problem from the 10-1 homework set. So we have a rectangular coordinate here, a Cartesian coordinate, an x and a y, and we're looking for a polar coordinate. And if you pay close attention here, we actually have two revolutions around a circle, right? Negative 2 pi to 0 being one, and 0 to 2 pi being the other. So we're actually going to have to come up with two different angles, two different representations of this, both with a positive r, but one negative angle, one positive angle. Alright, so let's first get the angle right. Like, how do we get the angle? Well, the trick we use here is the tangent of the angle we're looking for is the y-coordinate divided by the x-coordinate, so 1 over negative 1. So tangent is negative 1. Now you could use inverse tangent, alright, but remember inverse tangent is only defined in quadrants 4 and 1. There's quadrant 1, there's quadrant 4. Inverse tangent is only defined in these two quadrants, and it's in quadrant 1 if the tangent is positive. It's not here, it's negative, but there's where we would get if we had like positive 1, for instance. But if it's negative, we're in quadrant 4. So if we used inverse tangent, it would land us down there. It would give us this angle, which would be negative pi over 4. Alright, that is one possibility because we have from negative 2 pi all the way up to positive 2 pi. But the problem is this angle, or this point, is not in quadrant 4. Negative x, positive y, that means we went this way in the x direction, negative, and then we went up. The point we're actually looking for is over here in quadrant 2. And so one of the things we could do is start with that negative pi over 4 and then add pi radians to rotate us from quadrant 4 into quadrant 2. That's a possibility. We could do that. But this is how I do it. I don't use inverse tangent at all for this. I just look at tangent is negative, and I'm in quadrant 2, and I figure it out from that. So I know I'm in quadrant 2. That means I know I'm here in this part of the circle, and tangent is negative 1 right here at 3 pi over 4 in quadrant 2. The other way I know is this is point negative 1, positive 1. The x coordinate is negative, the y coordinate is positive, but they're opposites, and that happens right there. So this isn't exactly the same points, but if I were to extend this line that I've drawn out, that line is, and it goes into quadrant 4 as well, that line is y equals negative x. The y coordinate is the opposite of the x coordinate, and that happens on all of these points on this line, including negative 1, positive 1, which would be up there somewhere. So that 3 pi over 4, I can get it from that. It's the angle that makes tangent negative 1 in quadrant 2. It's also the angle on the unit circle that creates the x coordinate, y coordinates being negative, and the x being the negative 1, like we have here. So those things together let me know that 3 pi over 4 is the angle that I'm looking for. Alright, so I know theta can be 3 pi over 4. Alright, how do I get r? Well, r squared equals x squared plus y squared. This again is the Pythagorean theorem, and x is negative 1, y is positive 1. So r squared is 1 plus 1, which is 2. Alright, negative 1 squared is 1, positive 1 squared is 1. 1 plus 1 is 2. R squared is 2, so r is the square root of 2. So one possibility for the polar coordinates is the square root of 2 for r, comma 3 pi over 4 for theta. And then once we have that one, the next one that's possible would have been square root of 2, and then take the 3 pi over 4 and subtract 2 pi from it. So if I start off with 3 pi over 4, I could subtract 2 pi. 2 pi is 8 pi over 4 if we have to have a common denominator of 8. And then 3 pi minus 8 pi would be negative 5 pi. So that is the other option that could have worked here. Again, you could have had either one work. Either one of those would have been perfectly fine because that second angle, the negative 5 pi over 4, is in that negative 2 pi to 0 range. And that would have been a perfectly valid choice for this as well.